Hello and welcome to this section of the Algebra Tutor. In this section we're going to talk about what we call exponents and order of operations. Has a fancy sounding title. I promise you that by the end of it you'll be understanding things that you never really thought would be so easy to grasp through a bunch of example problems. This is the first section in this sequence where we're really going to start doing some things that sort of resemble algebra. A lot of students get turned off to algebra in the beginning because they open the book and they see all of these symbols and things that they've never seen before. Exponents, numbers raised up high, parentheses, all kinds of things that you normally don't see until you get sort of into an algebra level, right? So we're going to break these things down. We're going to talk about what exponents are and make sure you really understand. And then we're going to get into order of operations, which tells you how to calculate things in algebra and what comes first, what comes second. I'm not going to bore you with a long list of rules. We're going to do it by working problems. So, what is an exponent? An exponent is a big word that just means it's a shorthand way of writing multiplication. It's a shorthand way of writing multiplication. Let me show you what I'm talking about here. If you see something in a book that looks like this, 4 with a 2 on the top, this is an exponent. The 2 is what we call an exponent. And it's a shorthand way of writing this. 4 times, the dot is times 4, right? So we call this 4 squared. Anytime you see a 2 up there, it means squared. It just means that you take the bottom number and you multiply it by itself as many times as is indicated in the exponent. So it's 4 times 4. So in this case, 4 times 4 is 16. So 4 squared, or 4 raised to the power of 2, is 16. So for those of you that are scared and terrified of algebra, you should look at this and realize it's something you can understand. This 2 is not magical. It is just 4 multiplied by itself 2 times there, 4 squared. So likewise, 4 raised to the power of 3 would be 4 times 4 times 4, right? You multiply by itself 3 times because that's the number indicated at the top. And it can be any number you want. It could be, 59 raised to the 4th power, right? And that would be 59 multiplied by 59, multiplied by 59, multiplied by 59. Now this is a very large number. Take these numbers and multiply them in your calculator, you're going to get a giant number. This is why we use exponents. It's kind of a big pain to keep writing this multiplication out. We can write it like this and wrap it up much, much smaller and keep it nice and neat instead of writing all this multiplication out everywhere. So that's what an exponent is. That's the basic picture. One thing you must make sure that you do not get into the trap of is making the following mistake. Do not make the following mistake. 4 squared, for instance, is not, that means not equal to, 4 times 2. A lot of students will look at these numbers and say, well, 4 times 2, that's 8. Well, that's wrong, because we already said that 4 squared is equal to 4 times 4. 4 times 4 is 16. 4 times 2 is 8. So you can see that these two things are not equal. So you definitely don't just multiply by the exponent and you're done. What you're doing is you're multiplying the bottom number here by itself as many times as indicated by the number up there. So we already talked about it, but I'll just write it down. So for instance, 4 squared is equal to 4 times 4 is equal to 16. That's how you get that. All right? Let's do another one. Let's say we have 6 squared. What would that be equal to? That would be 6 multiplied by itself 2 times, because that's the number here. 6 times 6 is going to give us 36. You can see right away that 6 times 2, if you just did that, would be 12. That's nothing even close to 36. So just forget about multiplying these. You have to multiply by itself. Now, it does not matter what number you have here. It could be a fraction, it could be a decimal, it could be anything. So let's use parentheses for the first time in this class. And we'll take the fraction 1/10 and we'll raise it to the power of 4. Do not get scared by parentheses. Parentheses is something we're going to use a lot in this section. Parentheses is one of those things that scare a lot of students, like, whoa, parentheses, they belong in an English book, they don't belong in a math class. Parentheses in math basically means that whatever is inside, you want to kind of keep it together, right? In this case, the power of 4 applies to the entire thing inside of here. And since a fraction is kind of this complicated thing, we wrap it in parentheses here to indicate that the entire thing here is raised to the 4th power. It's kind of like, you can think of it like a little plastic baggie or something. You want to put a bunch of chips in a plastic baggie to carry it to a picnic. You don't want them spilling everywhere, right? If you have a large term that you want to kind of keep together in one unit, you just put parentheses around it to keep it there as a unit so that you know when you're looking at it that everything you're doing to that is applied to everything inside the parentheses. That's the only reason we're using it. So in this case, what this is going to be is to use parentheses again to get you familiar with it. 1/10, right? Multiply by 1/10, multiply by 1/10, multiply by 1/10. Now I'm putting a dot in here, but really when you put parentheses right next to each other like that, it means multiplication. But for now, I'll just keep putting the dots. So this is exactly what you might expect, just like we were doing 6 up here, 6 times 6. Well, this is what's inside, so it's 1/10 times 1/10 times 1/10 times 1/10. We're doing it 4 times because we have a power of 4 there. Now, we have actually done this kind of multiplication in the previous section on fractions. You know that when you're multiplying fractions, all you do is multiply the top numbers. So 1 times 1 times 1 times 1 is just going to be 1 on the top. 10 times 10 times 10 times 10, if you do that in a calculator, is 10,000. So if you actually go to a calculator and take the fraction 1/10 and raise it to the 4th power, you're going to get the fraction 1/10,000ths, right? 1/10,000ths. So that's basically showing you that anything inside of here raised to a power basically all behaves the same way. Now let me show you something quickly that's interesting. When you have something like this, 1/10 raised to the 4th power, 1/10 raised to the 4th power, it's exactly the same thing. This exponent can apply to the top and to the bottom separately. So it's 1 to the 4th power, 10 to the 4th power. It's the same thing. They're basically equal. I'm kind of teaching you a little bit of different rules as we go here that you'll pick up as we do more and more problems. But anytime you have a fraction like this with an exponent applied, you can apply the fraction to the exponent to the top and the exponent to the bottom separately. To make sure you understand that, what is 1 raised to the 4th power? Think about it. What is 1 raised to the 4th power? That's 1 times 1 times 1 times 1, which is 1. So that would be 1 on the top. What is 10 raised to the 4th power? That would be 10 times 10 times 10 times 10. We've already done 10 times 10 times 10 times 10. We figured out that that was 10,000. So we get the same answer either way. If you're going to break it up like this, you get this answer. If you're going to apply the exponent to the top and the bottom, you get exactly the same answer. They're both equivalent. All right, so let's do one more of those to drill that in. If you had the fraction 1/2 and you raise that to the 6th power, you could say 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2. You could write all that out. That's fine. That's no problem. But we can also write it as 1 raised to the 6th power over 2 raised to the 6th power. We effectively can apply this exponent to the top and to the bottom when we're raising fractions to exponents like this. So on the top, what do you think 1 to the 6th is going to be? It's going to be 1 times 1 times 1 times 1 times 1 times 1. So we're going to get 1. On the bottom, let me write it out. 2 times 2 times 2 times 2 times 2 times 2. Because we're multiplying the 2's together 6 times. And when you do that in a calculator, you're going to get 1/64. So if you were to take 1/2 and raise it to the 6th power, you would get 1/64. All right? Now, I want to switch gears a little bit. We've talked a little bit about exponents. I think I've given you enough examples that you understand what an exponent is and why it's useful. It certainly isn't nice to keep writing this multiplication out. We wrap things up in exponents to keep them nice and tidy. And once you know what they mean, it's really not a big deal to understand them. Next, I want to talk to you about the term that you'll see a lot in algebra. It's called factor. So let me write that down real quick. A factor. I am not going to give you a book definition for a factor. I'm going to give you Jason's definition, because my definition I think is a little easier to understand, even though it's not as nicely worded as a book. It is something that you multiply together to get a result. In a nutshell, factors are things that are multiplied together. That's really the bottom line. So for instance, if I had 2x squared. Now we're actually diving into the realm of algebra a little bit using an actual letter. Don't get worried about letters. Letters are not a big deal to worry about in algebra. All you're basically saying, could represent any number. X could be 1, x could be 5, x could be -3, x could be 1.4, x could be anything. So we don't know what it is, so we just keep it as x, and we're just going to leave it like that. But you also know that anytime you raise a number, which is what x really is, to a power of 2, it's the same as x times x. This is coming straight from the definition of what an exponent is. So these x's here, these are what we call the factors. So these are what we call the factors. This is really just a definition. To be honest with you, you're going to use factors a lot in algebra, but this is more of just getting the definition drilled into you. They're factors because these are the things we multiply together to kind of get what we started with, basically. Let me give you another couple of examples and I think you'll see. If I have 3z to the 4th power, how do I write this? Well, it's going to be 3 times z is raised to the 4th. 3 has nothing to do with this exponent. Z is the thing that's raised to the 4th. So it's z times z times z times z. So the 3 is multiplied by z times z times z times z. All of these things here that are multiplied together, they're just called factors. Just trying to give you some examples. In fact, they're called the product of factors because product means multiplied. These are the factors multiplied together to give you what you started with. Now what if I had, open parentheses, 5 times t squared? When I write two things next to one another, like 5 and t with nothing in between, it always means multiplication. Anytime you see two things sitting next to one another, in algebra, you got to get used to the fact that you're not going to always see multiplication symbols everywhere. If things are sitting next to each other, you just need to assume that they're multiplied together. But in this case, 5t is raised to the power of 2, but it's inside of parentheses. This means that this exponent applies to everything in here. So it would be 5t times 5t. So 5 times t times 5 times t, basically. And these are the factors. These are the things that are multiplied together to give you that. Notice that that's a little different than above. Here we didn't have any parentheses, so the exponent only applied to the z. But here the parentheses are forcing the exponent to apply to everything inside, and that's another reason why parentheses are so useful. Let me switch colors here just to break it up a little bit. Let's say we have 5 parentheses 2x to the 3rd power. How do you think that's going to be written? 2x to the 3rd power. Well, like I said, the 5 is sitting next to something without anything in between, so you should really think of it as being multiplied together. And this is all raised to the 3rd power, so this is going to be 5 times 2x times 2x times 2x. I'm multiplying 2x times itself 3 times because that's the exponent. 5 is multiplied by everything because it's just sitting next to the parentheses there. And the 2x, the exponent is applying to the 2x as a whole unit because it's wrapped up in these parentheses. The parentheses like a little sandwich bag. Everything in there has to kind of sort of stay together, more or less. And everything on the outside, like this exponent, is going to apply to that whole thing. All right, so we've talked about quite a bit of stuff. We've talked about exponents. We've talked about the factors when you multiply them together. These are just labeled factors. That's just more or less to help you when your book starts talking later on about factoring expressions or telling you what the factors are in a test. You'll know what they're talking about. They just mean things that you multiply together to get what you're started with or whatever term you have. Now, we want to do something practical now. What we want to do is, let's pretend, what we're going to do is plug in. Let's say that x is known to be 3, and let's say that y is known to be 2. So what I want to do is evaluate the following terms, 4x squared. So remember, anytime you see a letter in algebra, it just means that it represents a number. That number is something that you don't necessarily know. Later on down the road, we might use an equation to solve for that number, right? Whatever x is, we're just trying to figure out what it is. In this case, we're actually given that x is equal to 3, and y is equal to 2. So if we have what we call an expression, this is just a word that means something you write down that you need to evaluate. We call it an expression. What we need to do is take the value of 3 and stick it everywhere we see x. Everywhere we see x and evaluate the results. So what we'll have is 4 times 3 squared. Right? That's what we're doing here. 3 goes in for x, so we're squaring that. So this is 4 times 3 times 3, because 3 squared is 3 times 3. So, starting from left to right, 4 times 3 is 12. So we have to continue. We put 12 here because that's equal to 12 times 3. 12 times 3 is 36. So the answer is 36. All right? Okay, now the next thing we need to do, just as another example, is say, what about 5y raised to the third power? How do we do that? Well, we know that y is equal to 2. So let's go ahead and put it in there. 5 times, remember this is an implied multiplication because they're sitting next to one another, 2 raised to the third power. So what we need to do is evaluate this and figure out what this is equal to. Now, in a minute, we're going to actually get to what we call order of operations. And I'm going to list and tell you exactly the order in which you do every calculation in algebra. But for now, I'm going to give you the biggest, most important rule that you can follow. And I'm going to drill this in because it's just so important. Always, 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 always do whatever is in the parentheses first. I'll say it again. Anytime you see anything to calculate, if you see parentheses, you must do what is inside the parentheses first. You always have to do what's inside the parentheses first. It always comes first. So that helps because here we're not sure, well, do we do the exponents or do we do the multiplication inside the parentheses? Well, the answer is you do inside the parentheses first. 5 times 2 is 10. The exponent is still along for the ride, but we've evaluated what's inside of here and made it 10. Now we have 10 cubed, which is 10 times 10 times 10. 10 times 10 times 10. And when you take 10 times 10, you'll get 100. Of course, you still got one more 10 to multiply by. And 100 times 10 is 1,000. And that is the answer. So if you take 5y, where y is equal to 2, and you raise the whole thing to the third power, you'll get 1,000. You must do what's inside the parentheses first. That's why we did this 10 first, and then we raised the result. So important. We're going to get to a little bit more of that here in a minute as well. All right, what if we have 2x raised to the y power? Now this looks more complicated, right? But don't worry about it. It's like a jigsaw puzzle. You just put in what you know. 2 times, you have to multiply here because it's a implied multiplication because it's sitting there. X is 3 raised to the y power, which is 2. So we just plug the numbers in there. Okay, now the other thing is, and I'm going to get to a whole list of order of operations in a minute, exponents come right after the parentheses as far as what's most important to do. In this case, there's no parentheses anywhere, so we don't have to worry about parentheses. The next most important thing to do is the exponents. So that's very, very important because when you look at this, you might say, well, maybe I multiply 2 times 3 and I get 6, and then I take 6 and raise it to the power of 2. But that's not right. You have to do the exponent first, which is 3 squared, which is 3 times 3, right? So what we'll have is 2 times 3 times 3. That's what we're going to get. And then what we're going to have is 2 times 3 is 6, 6 times 3, so we'll do it like this. 6 times 3 is 18. So we evaluate the exponent first, writing it like this. And then we do the multiplication left to right. 2 times 3 is 6, and then with 6 times 3 here is 18, and that is the answer. So always evaluate the exponent first. So as far as the hierarchy goes, and I'll write it down in a minute, parentheses comes first, exponents come next, and then everything else will fall out after that. We'll just see how it goes. All right, let me change colors real quick. What if we have 3y raised to the power of x? And notice that in this case, 3y is wrapped up in a parentheses. So 3 times y is 2, raised to the power of x, which is 3. That's how we're writing this. And now you need to think about, a lot of students will be like, well, do I do the exponent first or do I multiply first? Well, we already said that. We always do what's in the parentheses first, always. 3 times 2 is 6. Now that 6 was what was in here. It's all raised to the 3 power. Now we know exactly what to do because this is 6 times 6 times 6. 6 times 6 is 36. Still have to multiply by my final 6. 6 times 36 is 216. And this is the final answer, 216. So plug in the values, evaluate what's in the parentheses, and then do the exponent. And that's going to get you very far. Now, I've kind of hinted I wanted to introduce you to things first before hitting you over the head with a bunch of rules. But now we're going to actually tackle the topic of what we call order of operations. We've actually been doing a little bit of it already. I just never told you. I kind of snuck it in there to kind of make you comfortable with it. In your book, a lot of times, whatever book you're using, will list order of operations. I'll give you a list a mile long of things for you to memorize. I'm going to make it much easier than that for you. So here we go. Order of operations. Order of operations. Basically, you need to have some kind of list to tell you what order to calculate things. Otherwise, you're going to get the wrong answer. So the first thing you do is what we talked about. Parentheses are the most important thing. If you see parentheses anywhere in any calculation, you must do what's inside the parentheses first, always, okay? That's very easy to remember when you really do it for a minute. The next most important thing to do is exponents. So if you have parentheses, do them first. After that, if you see any exponents anywhere, do them next. If there are no parentheses anywhere in what you're doing, then you do exponents first. So it's a list, a priority list of what you do. Okay, the next thing you do is multiplication and division, if you have any multiplication and division. And after that, the most, or I should say the least important, quote unquote, thing is add and subtract. All right, folks, that is my list of order of operations. Your textbook might have a longer list trying to make things, pretty with special rules and things to remember and all that. And I'm going to drill in how to do this for you with examples so you won't actually have to memorize the list. But hopefully you've memorized enough to know that the parentheses always come first, the exponents come next, then if you have any multiplication and division, you do them, and then if you have any addition and subtraction, you do those dead last. You might think addition and subtraction are so important, but in fact they come dead last. Never do any addition and subtraction until you've done everything else. Now there's one sort of exception to this whole thing. If any of these things, like let's say you have some addition and subtraction wrapped up inside of some parentheses, right? You have to do what's inside the parentheses first, so you do that first. So this priority order makes sense, but I'm just telling you, if you have any of these things lying inside of a parentheses set, then you just do those first because it follows rule number 1, trumps everything else. All right, so let's get some practice. I'm a firm believer in learn by doing. We can talk and talk and talk and talk, but if I just show you a few examples, it'll be so easy. Let's say we have 3 times 5 minus 4. And I'm asking you, let's do this calculation. Well, the first thing you do is you say, well, there's no parentheses anywhere. Okay, that's great. There's no exponents anywhere. Okay, that's great. I look for multiplication and division. I see, hey, here's some multiplication, so I do it. 3 times 5 is 15. You have to keep this along for the ride because you haven't done them yet. Now you look at this and you say, well, the only thing left is subtraction. I can do that because there's nothing else to do. 15 minus 4 is 11. Bingo, you've got your first answer. Very simple. All right. Now, let's take something a little bit different. Let's say we have 3 parentheses 5 minus 4. Now, the first thing you do is you say, well, do I have any parentheses? And you say, yes, I do. Now, this is a great example. Inside of these parentheses is subtraction, which I told you was dead last. However, since it's inside of a parentheses set, it takes priority and you do it first. So we always do this first inside the parentheses. So we keep the 3 along for the ride, keep our parentheses. 5 minus 4 is 1. Now, this is just straight multiplication. There's nothing else to do. So 3 times 1 is 3. That is the final answer. Okay? Now let's say you have 3 plus 5 squared. This is an excellent example of when order of operations must be followed. Let me show you how to do it properly. First, you look for parentheses, and there's no parentheses, so you're okay. Then you look for exponents, and you look here, and you say, okay, 5 squared. I need to do that guy next. So I'll keep the 3 plus 5 squared. What do you think 5 squared is? That's 5 times 5. You're multiplying it, 2 times there. So 5 times 5, that's 25. Now all I have is addition. It's dead last. I can do that. 3 plus 25 is 28. And this is the final answer, 28. Now, if you did this incorrectly, if you don't follow this list, you might just try to add 3 plus 5 and get 8. And then you'll try to apply the exponent, 8 squared. 8 times 8 is 64. That's nowhere close to the correct answer. So you cannot just start adding things and doing things in any order you want. You're going to get the wrong answer. You must do it in this order. Exponents first, and then addition. Okay, we'll switch colors for a minute. Let's say we have 2 plus 3 times 5 minus 4. 2 plus 3 times 5 minus 4. Now we're starting to get a little more complicated. You might look at this and you say, well, maybe I should add 2 plus 3 and then multiply by 5 and then subtract 4, but that is not correct. You look through your list. Any exponents? No. Any parentheses, I should say first. Parentheses? Nope. Exponents? Nope. Look for multiplication and division. I have multiplication going on right here. I must do him next. 2 plus 3 times 5 gives me 15. Minus 4 comes along for the ride. Now the only thing you have left is addition and subtraction, which is dead last. That's okay now. When you have addition and subtraction on the same level with no other parentheses or anything, you just do them left to right, like reading a book. All right? So 2 plus 15 is 17. You still have to subtract your 4. 17 minus 4 is going to give you 13. And 13 is the final answer. All right, let's do another. Let's say we have 64 divided by 3 plus 1. How would we do that? Well, the first thing we do, we see this division. We might be tempted to do something with that first, but we see the parentheses first. We must do parentheses first. So 64 divided by, and what is 3 plus 1? 3 plus 1 is 4. Now I have a straight division problem. I can obviously do that. There's nothing left to do. 64 divided by 4 is going to give me 16. And that is the final answer. 64 divided by 4 is going to give me 16. All right, we'll do one more on this board. We'll have 7 plus 9 divided by 2 times 4. So we notice we have lots of parentheses here. So we can do the parentheses kind of in parallel if we want. We can do this parenthesis and this parenthesis in the same steps. We just need to make sure that they're done at the top of the list. 7 plus 9 is 16 divided by 2 times 4 is 8. We must do what's in the parentheses first. We did do them first. We just did them at the same step. That's okay to do. All right, so we have 16 divided by 8. There's nothing else to do here, so we have 2. Now what we're going to do now is erase the board, do a couple more quick examples involving order of operations to wrap this section up. Okay, what if we have 5 plus 7 divided by 3 times 4? So the first thing we do is try to look for parentheses. And we see that we have parentheses, so we do that first. 5 plus 7 is going to give us 12. So we just write a 12, and we carry the rest of the problem along for the ride. So we look for parentheses first here. We don't have any parentheses left. We don't have any exponents. So we look for multiplication and division. And in fact, we have multiplication and division on the same level, so we do them left to right, like reading a book. 12 divided by 3 is 4. We still have to multiply by 4 at the end. 4 times 4 is 16. And 16 is the answer. All right. What if we have something that looks complicated but really isn't? 100 divided by 10 times 10 divided by 100. So it looks really complicated, but you just kind of go through it. Check for any parentheses. We don't have any parentheses. Check for any exponents. We don't have any exponents. Check for multiplication and division. We have lots of multiplication and division, so we do them all left to right on the same level. So 100 divided by 10 is going to give us 10. I have to carry the rest along for the ride. I haven't done anything with that. All right, same thing here. We do left to right. 10 times 10 gives us 100. And I carry this along for the ride. And then finally, the only thing left to do is do this division, which gives you 1. And this is the final answer. All right, we'll do one last one of this type and show you that you really can understand this stuff because it's not that hard. It's going to look hard, you know, if you never took algebra or never watched this lesson, but it's not a big deal. 3 squared plus 2 parentheses 1 plus 4 minus 2. It looks very, very difficult at first, especially if you haven't taken algebra, because you've got an exponent, you've got parentheses, and you've got subtraction and addition all at the same time. You might, you know, if you didn't know what any of this stuff was, you might start adding things out of order and really getting yourself into trouble. So the first thing to do is look for parentheses. We see we have a parentheses here, so we'll just rewrite the rest of the problem and do inside the parentheses first. 1 plus 4 is 5. Everything else is rewritten. Now we look, now this is a parentheses, but there's nothing to do. It's just a number, so this is really just multiplication. So the next thing we do is we look for exponents. Here's an exponent. 3 squared, what do you think that's going to be? 3 times 3 is going to give us 9, plus 2 times 5 minus 2. So I'm just rewriting, taking the parentheses out because it's just multiplication now. So here we have 9 plus 2 times 5 minus 2, and you might be tempted to add 9 plus 2, but that's going to be wrong because you need to look in your order. Are there any parentheses? No. Are there any exponents? No. Is there any multiplication and division? Yes, there is. It's right here. We must do that first. 9 plus 2 times 5 gives us 10. Now the only thing we have is addition and subtraction. They're on the same level, so we read it like a book, left to right. 9 plus 10 is 19. Carry the 2 along for the ride. 19 minus 2 is 17. So if you take this monster and put it into a calculator, you'll get 17 as an answer. If you start doing this stuff out of order, you will definitely not get the right answer. All right, we want to do one more problem type and we'll wrap up this entire section. Just kind of building the complexity a little bit. None of this stuff is hard, but you do need to see a lot of practice. So let's pretend that x is equal to 3. This is given to us. Y is equal to 2. That's given to us. Z is equal to 4. This is given to us. And for the first problem, let's evaluate this expression. 5z divided by 2 plus y. 5z divided by 2 plus y. So the first thing you do is plug in what you know. 5z, 5 times z would be 5 times z, which is 4, divided by 2 plus y, which is 2. So we've converted everything over to numbers, and now we go through our order of operations. Are there any parentheses? No. Are there any exponents? No. Is there any multiplication and division? Yes, there is. There's multiplication here and there's division here, so we do those first. So let's start left to right. 5 times 4 is 20. Let's rewrite the problem. We did this, making it 20. Now, we again see we have division. That's going to take priority. 20 divided by 2 is 10. And this is just staying along for the ride. Now, this is the only thing left to do, so we get 12. 10 plus 2 is 12, and that's the answer. Looks really complicated, but you'll see that it's really not. And let's do 3, 2x plus y, all wrapped up inside of parentheses. So let's plug in what we know. We have 3, 2 times x, x in this case is 3, plus y, y in this case is 2. And all of this stuff is inside parentheses, though this is another great example. The first thing you do is you check for what's inside parentheses, and we have a bunch of stuff inside parentheses, so we know we have to do that first. But what we have inside of the parentheses is a combination of multiplication and addition. And you should know by now that multiplication takes priority over addition. So we do the multiplication inside here first. So the way you would write this is 2 times 3 is 6. Keep the 2 along for the ride for the next step. Again, we're going to do what's inside the parentheses. 6 plus 2 is 8. Now the only thing left to do is this multiplication. 8 times 3 is 24. And 24 is the final answer. All right, let's do the next guy. Here we have x times y times z plus z squared minus 4x. Now this would give a lot of students a lot of heartburn having, if you haven't studied this, because it just looks so complicated, but just take it one step at a time. First, substitute what you know. X is equal to 3, y is equal to 2, z is equal to 4. Since z is 4, we're going to have 4 squared here. And since x was equal to 3, we're going to have 3 here. So the first thing to check for is to see, do you have any parentheses? No, you don't. Do you have any exponents? Yes, you do. So do that one next. So we have 3 times 2 times 4. Don't mess with that stuff yet. What is this? 4 squared. 4 times 4 is 16. And keep everything along, everything else for the ride. Don't do anything yet. Now we go back through it. No parentheses, no exponents. Do we have any addition or, do we have any multiplication or division? That's the next most important thing. We have lots of multiplication here, so let's do that stuff. So what we have is 3 times 2 is 6, but 6 times 4 is 24. So all of this multiplied together is going to give you 24 plus 16. And we can do this multiplication on the end. 4 times 3 is 12. Make sure you understand that. All we did was do 3 times 2 is 6, times 4 is 24. The 16 stays where it is. 4 times 3 can be multiplied together to give us 12. Now we have a bunch of addition and subtraction, which is dead last, so we do it left to right like reading a book. 24 plus 16 is 40. Still have to subtract 12. And 40 minus 12 is 28. And that is the final answer. All right, here is the very last problem. Same values for the variables. X is going to be equal to 3, y is equal to 2, z is equal to 4. No changes, everything's the same as before. But here we're going to evaluate 2x plus y squared is equal to y plus 2z. Looks extremely complicated, but you'll find it's not a big deal. 2 times x, x is equal to 3, plus y squared, y is equal to 2, all divided by, here we have y, which is 2, 2 times z, which is 4. Now this looks really monster here. So the first thing you would do is look in your order of operations and see if you have any parentheses. No, you don't. However, there's something I really didn't want to write in my list, but I want to tell you verbally. Anytime you have a big fraction, this is what I call a big fraction, where you have a big fraction bar, giant terms on the top, lots of stuff on the bottom. You kind of need to treat the top and the bottom as having kind of implied parentheses. They're not written here, but you basically have to do the top and the bottom of the fraction separately before you can do the division that the fraction represents. So I'm not going to draw it, but you have to imagine some parentheses around the top and imagine some parentheses around the bottom. Then you will realize that you must do the top and get the top done, and then the bottom separately done, and then finish the problem out. That helps you immensely. And that's just sort of a rule of thumb you have to remember. So in the top, what do I need to do in the top? Well, there's, the most important thing in the top is the exponent is highest on the list, so I need to do that first. 2 times 3 plus 2 squared, 2 times 2 is 4. Keep your fraction. On the bottom, what is most important on the bottom? Well, multiplication comes more important than addition, so let's do that first. 2 times 4 is 8. Now we continue working on the top. This multiplication is more important than this division, so we do that first. 6 plus 4. On the bottom, we can just do this addition. 2 plus 8 is 10. And now it's very simple. 6 plus 4 on the top again is 10 over 10. Now this is a division, right? That's what a fraction is. 10 divided by 10 is 1. So that's a very important rule of thumb for you to remember. When you have a large fraction, that's why we spent so much time on fractions in the last section, to get you really comfortable with that. But when you have large fractions like that, you really need to consider the numerator at the top of it to have like an implied parentheses. You must do what sort of like simplify everything on the top first and everything on the bottom independent of one another, and then at the end do the division. And that's just sort of the way it is. So once we put everything in here, we realized, well, the exponent was most important on the top, so we did this guy. And on the bottom, the multiplication was more important than this addition, so we did that. And then when we got to this step, the multiplication was more important than the addition, so we did that. And we did this addition on the bottom, and then we did this addition, and then the division, and so on. So that concludes this section. We've done a tremendous amount of material. A lot of people watching this have never heard of an exponent or get really terrified of parentheses. I've tried to break down those barriers with lots of examples. An exponent is just a short way to write lots and lots of multiplication. Parentheses are just used to group things together. That's basically it. The order of operations that we use is we do everything inside the parentheses first. Next we look at the exponents. Then we do multiplication and division, and then we do addition and subtraction. Of course, there's some exceptions. When you have giant fractions, you pretend that there's giant parentheses around the top and around the bottom. So those come first. Once you're working on something inside of a parentheses set, you need to follow the rules to figure out what to do first and second. In this case, the exponent was most important, for instance, right? As you do more and more problems, you'll get more and more comfortable with this. So definitely watch this lesson as many times as you need. Practice every single problem in this lesson. Watch it a second time. Write these problems down as I'm writing them down. Solve them yourself. There's dozens of problems in this section that if you master, you'll definitely get good at exponents and order of operations, which honestly is some of the most important foundation to all of algebra. So make sure you understand it. Follow me on to the subsequent sections. We'll be taking our way through algebra step by step, building up your confidence, building up your skills, and helping you do well on your homework and on your exams.